Ball screw, high reliability mechanical engineering artwork shows how Emerson uses technology in Bettis electric actuators. In our last session, we talked about how a ball screw allows actuator to have high accuracy, high torque and thrust on fail-safe applications. Also, how it keeps a high accuracy of 0.1% without adding extra backlash effects. At the end of the day, it is what it is, and we will cover the high reliability feature in this short video. Why is ball screw a highly reliable solution? Reliability is defined as the probability that a product or system will perform its intended function adequately for a specific period. So the most important thing here is the life expectancy of the ball screw, which has a very long life in comparison with acme screws. Ball screws has at least 1 million of revolution of life expectancy, which is typically rated at 90% confidence by L10 standard calculations. Those calculations are based on this basic formula. C is the dynamic load rating and it is a manufacturer constant. The F is a real operating force based on the current force being applied. There are factors out there that reduce life expectancy, like shock loading, vibration, temperature, lubrication, and misalignment. Mechanical components do not exhibit a constant failure rate. This is the main reason why this type of components often have a reliability metric quoted in terms of L10% or L5% instead of MTBF. Now, life expectancy can be expressed in revolution, which is associated with the speed, how fast do you operate ball screws, and duty cycle, how often and how long do you operate ball screws. Those two factors are critical in extending reliability as a function of time. As you can see in this table, ball screws can achieve higher speeds and high duty cycle due to low friction and high efficiency. On the other hand, acme screws suffer from high friction, which cause excess heat and wear at high speed and high duty cycle applications. Now that you understand it, we can confirm that the ball screw design has high reliability. Basically, there is no way that I can demonstrate the reliability feature with my own hands, but I can tell you that most of the critical reliability applications out there are using ball screw, starting from military application, Air Force, high-speed motion machine, missile launcher, high-precision mechanical equipment, heavy-duty low application, and many others where high speed, high load, and high duty cycle plus high life expectancy are mandatory. Why it is important for Emerson actuators? There are two important factors associated with the ball screw and the high reliability of the actuator which work with the RTS electric and electronic technology. The first one is associated with the control application on slide stem control valves like Fisher glove valves. These valves need a reliable actuator which can move in small steps to seat those valves safely without any seat damage. Also, it should handle reliable and accurate control. The second one is associated with a truly mechanical fail-safe electric actuators. A reliable ball screw is a critical and an important component which work in conjunction with the RTS electric brake and the planetary gear. When an RTS mechanical fail-safe actuator loses power or receives an ESD signal, the actuator releases spring force accumulated and achieves a fail closed or open position with high level of integrity. This actuator accomplishes Seal 3 by standard, and it is possible because this reliable technology is part of the RTS. In our next session, I will explain to you the importance of the less expensive feature and how it is important for actuators and valves. So I don't have anything more to say than thank you and have a wonderful day.